Hey folks, alright, so today we're going to talk about factoring trinomials where a is equal to 1. Alright, and specifically we're going to be talking about quadratic trinomials of the form you're about to see. Alright, so that's called the standard form of a quadratic trinomial. And when we say a is equal to 1, we mean that the number in front of the x squared is 1, which actually makes it simpler to factor. If that's 1, the factoring that we have to go through is an easier process than when that's not equal to 1. And we'll get into when it's not equal to 1 later on down the road. B would be the number in front of the x, and C is the number all by itself, doesn't have any variables with it at all. Okay, so for example, say let's go back to something we were talking about the other day. If I gave you something like this. All right, so if I gave you x plus 3 times x plus 5 and told you to multiply to simplify here, you would do what you guys call FOIL, what I like to call just distribution, where you're distributing the x from the first parenthesis into both things in the second parenthesis, giving you x squared plus 5x. And you're doing the same thing with the 3. You're taking the 3 and you're going to the x and you're going to the 5. All right, and then you're combining like terms. So you have x squared plus 8x plus 50. Okay, so what I'm going to ask you to do now is what I'm going to show you how to do now is I'm actually going to show you how to go from here back to this. All right, so how do we go reverse now? All right, so we talked about that with GCF where you're basically multiplying and when you're distributing, and then with GCF factoring you're doing the opposite of that, which would be then division. All right, so the same thing applies here. We're going backwards. We're starting with the already simplified form and we're going back to its factors. What this leads us into is it'll allow us to some time in the future take a quadratic and actually solve for x. But we need to be able to factor it first before we can solve for x. So how do we go about doing that? One thing I want you to notice about this, when we get into the next page, it'll make a little bit more sense. Look at the b, which is 8, and look at the c, which is 15. Okay? So look at those two numbers and then look back at the two factors that got us there. You had positive 3 and positive 5. All right? What do you notice about those two numbers? Well, I multiplied this all together, but positive 3 and positive 5, when I add them together, what do they equal? Equal 8, right? Look down at the b. So 3 plus 5 is 8. Okay, that's always going to be the case when a is equal to 1. Now, go back to those same two numbers. You have positive 3, you have positive 5. When I multiply them together, what do they give me? As you guys know, 3 times 5 is 15. Look at the number that's down there for C. It's 15. That will always match as well. So how can we use that information knowing that when they add together, they're always going to give me B, and when they multiply together, they're always going to give me C? How can we use that to reverse this process and get these two factors, all right, so that we have a factored trinomial that we can sometime down the road actually solve for x? All right, where do the two x's come from? How do we know that it's going to be x here and x here? All right, well, we'll talk about that in a minute. Essentially, just think about the fact that x squared is two x's, right? Well, for factoring, we're pulling that apart. All right, so what do we pull it apart into? We pull it apart into its components, which are x and x. All right, so let's take a look at some examples. And we'll go through how to go about going from this form here back to the factored form, all right, which will be useful later when we go to solve. So here's some examples. All right, and notice I have the B and the C both highlighted in different colors. Okay, so let's take a look at the first one, which is x squared plus 9x plus 14. All right, so what I want you to think about, remember, before in the previous page, the numbers multiplied to give me C, All right, so they multiplied to give me 14, okay? And they added to give me 9. Well, in the previous problem was different numbers, but multiplied to give me C and added to give me B, okay? So what I want you to think about is what are the numbers that do both of those things for this problem? All right, so what we'll start to do is just list out some factors of 14. 14 we know is 1 times 14. We also know you can do 2 times 7. All right, they're the only two sets of factors that will multiply to give me 14. So which one of those two sets of factors also at the same time as multiplying to give me 14 add up to give me 9? Easy, right? These two. So when I go to pull this apart and factor it, I have my two parentheses. Okay, I know that x squared is going to pull apart into components. X. All right, and then I know that my numbers, right, will add up to b and multiply to c. The only two that do that are positive 2 and positive 7. Okay, so I have now successfully factored x squared plus 9x plus 14. Now, what's the only way to know for sure that I did this correctly? You can always FOIL that back together again, all right, and see if it gives you the original, which is x squared plus 9x plus 14. We'll do it for this one. We don't have to do it for all of them, but it's a way to check. So x squared plus 7x, 2x, 7. Okay, combine terms. So that's exactly what I started with, which means I did this correctly. So my check is good. Okay, and again, you're looking for numbers that add to give you 9, multiply to give you 14. First thing you want to start with is look at this number, okay, and start thinking of factors of that number. Numbers that multiply to give you that number and also add to give you the middle number. Right? So now we're going to jump down to x squared minus 5x plus 6. All right, I'm going to start off. I know it's going to be two parentheses. I know I'm going to have an x because it's x squared broken up. Now I need to find factors of 6 that add up to negative 5. All right, so now we have to think about this here. Signs come into play. Okay. So when I think about the signs, positive, so the only time I'm going to end up with two numbers that multiply to give me a positive and add to give me a negative is if both of those numbers are negative. So when I think about factors, I just have to think about them both being negative. -1, -5, -3, and -2, and that's it. I'm sorry, not -5, I apologize, -6. I'm looking for factors of 6. All right, so -1 times -6, that gives me positive 6. -1 plus -6 gives me -7. That doesn't work. -3 times -2 is positive 6. So that works for that. -3 plus -2 gives me -5 when I add them together. So my set that I want to go with are these. All right, so I'm going to go with this here. That's it. Now, again, I could go through the process of checking by refoiling this all together and seeing if it comes out to be the original. I'll tell you now that it will. It is up to you if you want to check. It is helpful sometimes if you're unsure. You don't always have to do it. All right, moving down to x squared minus 3x minus 6. Again, throw off with throw x in there. Signs this one are a little bit different. Now I have a -10. The only way to multiply to get a negative number is by multiplying a negative number times a positive number. So my factors here, one of them is going to be negative, one of them is going to be positive. So I'm going to think about factors of -10 that add up to -3. So I could think about things like -1 and positive 10, or -10 and positive 1, right? You go the reverse way. -2, positive 5, or -5 and positive 2. Now, if I think about those, that adds up to 9, doesn't work. That adds up to -9, doesn't work. -2 plus 5, why doesn't that work? Because it adds up to positive 3. We're looking for it to add up to -3. So cancel that one out as well. -3 plus 2, or excuse me, I'm sorry, that's a 5. -5 plus 2 is -3. That's what I'm looking for. This is my set here. So I'm just going to go and place them in. Now remember, it doesn't really matter which order you put them in as long as the sign in front of the number is the right sign. If I had positive 5 here and -2 here, that wouldn't be right. But if I had +2 and -5, they were flip-flopped, that would be okay. It would work out. Last one we want to look at, x squared plus x minus 20. All right, what you're going to want to think about is I'm trying to add up to 1 there. All right, it's not shown, but that's a 1. So let's think of some factors with negative 20. I got negative 2, 10. I got negative 10 and 2, remember, because we want to multiply to get a negative number, so it has to be a negative and a positive. Negative 4 and 5, and negative 5 and 4. Okay, so obviously adds up to 8. No, adds up to negative 8, not what I'm looking for. Negative 4 plus 5. This is the 1, because when I add those together, it gives me positive 1. This one will not work, because when I add them together, it gives me negative 1. So my answer for this one is x minus 4 and x plus 5. Okay, and they are the factored versions of those 4 trinomials. Okay, so again, they're all in that same form. They're in that ax squared plus bx plus c form, where a is equal to 1. So all the numbers here have 1. This is all 1 in front of the x squared. The only way we can choose to or do this factoring method for a equals 1 is if that's equal to 1. It has to be equal to 1. There'll be a different method that we talk about when that number changes and it's something like 2 or 5 or something like that, where it's not equal to 1. Okay, so that's how you do it. Let's take a look at the next page. All right. Now the next page, we'll talk about it at a later time, but just so you're aware, this actually is going to combine both a equals 1, okay, with GCF. So I'm actually going to have to look for a GCF first, take that out, and then it's going to end up still factoring further to something that has a is equal to 1. But we'll talk about that at a later time. All right. And we'll go over any questions you have from this video in class later on.